Section 1.5, example 1.32, or example 32, using substitution with integrals of trigonometric functions. So use the substitution to evaluate the integral sine t over sine cubed t dt. Well, what I do see is down here we have a cubic function, up here we have a single function, but more importantly, we know that if we let u equal cosine t, the derivative negative sine t dt. And this is actually what we have in that numerator. So it's perfect. I think we found exactly what we needed now. So looking at the integral with the denominator cosine 3t, numerator sine t dt. So we're looking for something that we could differentiate to a multiple that we have in here already. So we're going to let u equal cosine t. We don't want cosine 3t, that's going to make it a little complicated. But if we look at just cosine t, we're able to use that in there. Now du is going to be negative sine t dt. If we multiply both sides by -1, negative du is equal to sine t dt. And now we could do the substitutions. And so here we have, we'll say cosine t. Let's raise this to the -3 just to make it a little bit easier. And we're multiplying that by sine t dt. And now everywhere we see a cosine t, we're going to replace it with u. Everywhere we see sine t dt, we're going to replace it with negative du. So we have u to the -3 times negative du. Can move that negative out here. U to the -3 du. Super easy to integrate. So we have that negative. We have that u to the -2. Multiply by the reciprocal, which is a -1/2. Add c, so plus c, because we know that there's a constant, or there might be a constant that we differentiated out. 1/2 u to the -2 plus c. We weren't in terms of u, we were in terms of t. So let's throw that back in there. U equals cosine t. So what we have is 1/2 cosine to the -2 t plus c. We actually have a function that we could name this. So the reciprocal function of cosine is secant. So 1/2 secant squared t plus c. And there we go. That's it. If you have any questions, please feel free to ask. Otherwise, bye.